Alright everybody, welcome back to another Ask a Dev Unreal Engine training tutorial. We are continuing our control rig advanced leg topic. This is part 2. We're going to be working on the forward solve for our FK-IK leg. If you missed part 1, you may need to go back and watch the initialization video. There should be a card around here to go ahead and get back to that video. My name's Kevin. Before we get started, big shout out to the community. Thank you everybody for showing your support. If you like what we're doing here, go ahead and help spread the word. That's awesome. We also have super chats and thanks and stickers that are there, and the Patreon link is down in the video section down below. So let's hop in and take a look at what's going on with our forward solve. So here we are in Unreal Engine. This was our initialization setup for our advanced leg. Now there are multiple parts to our forward solve. We have the forward FK solve and we have the forward IK solve. Remember, we're going to be doing the alignment in part 3. So here's what we're going to do. Let's start with the IK solve. So we're not going to start from scratch because there's a lot of stuff that we can reuse. Now, the original IK leg came from the IK leg series that we started on with the entire, it basically went through the whole thing all the way to FK-IK snapping. So let's go ahead and go into our blueprint. And what I'm going to do is I'm going to duplicate the forward IK leg, Control C, Control V, and I'm going to call this the forward advanced IK leg. And forward is for forward solve. And then I want to double click on that. And let's just do a quick recap. Basically, all it is this is our basic IK setup to make the leg work. And then over here, we have, this is all the stuff for our reverse foot setup. All right, we're not going to be messing with this. All of this is going to stay the same. Most of the work we're going to be doing is over here. So if you missed that, you can go back and watch those videos. I'll put a link in the description so you can go see how that was all done. I'm moving this over to make some room for it. Now, before we get started, there are a couple things that we need. First off, it is always good to go ahead and let me make sure that we're actually calling our advanced leg in our rig. Because right now, and let's just skip the right leg for right now. I'm just going to disconnect it. And rather than calling the forward leg, let's call the forward advanced IK leg. And as before, I'm hijacking these pins by control dragging. And we will just go ahead and delete. We're going to go let it ride all the way in. Now, this is pretty common. Whenever I do a swap like this, I'll see a compile error, even though maybe we shouldn't see one. And a lot of times if I come in here and just click compile, see, this is just a compile error on a make vector down here. If you just click compile in here, all of a sudden, everything's great. So we're going to be clicking compile a lot, but let me go ahead and save that too, because there's a lot of things that can happen in control rig. Okay, so what we are going to do in order to make this a little bit easier is we are going to be setting up a couple local variables to help us out. So let's create those at first. And those local variables are going to be for the upper leg IK, the calf IK, and the foot IK. And it's mostly just so we don't have a bunch of Unreal Engine noodles floating around. So I'm going to call this the up leg. Let's call this the up leg. Sure, we can call it the up leg IK. And you know what? I'm not going to call it the up leg. I'm going to call it the up leg ref, because maybe we reuse this later, the same logic. So we'll call it the up leg ref, and I'm going to make this a name, and then I'm going to make a new one, and this is going to be the low leg ref. And let's go ahead and make the foot ref. All right, and then what we're going to do is we're going to set each of these. So let's just set that, and set that. Now, if you recall from our initialization video, the names of each of these three was basically the name of the bone with an underbar IK on it. So that's what we're going to do. We're going to take this and we're going to basically specify that. So let's get the bones. And the up leg ref is the item at 0. And we're going to take that name and we're going to concatenate, which means we're just adding two strings together. We're going to concatenate underbar IK. All right, and let's try to make this somewhat nice. Now I forgot what the hotkey was for alignment left. Shift A. Okay, cool. So we'll line those up, and then let's just duplicate this. We're going to duplicate this a bunch of times, 2 times. We will set our index. So the low leg is the calf, and the foot is the foot. And we'll connect these in like so. And then let's just go ahead and connect this. Control drag that pen, each of these, and line these up. All right, now that we have those defined, this is where the work starts to happen. So the first thing we want to do, remember what we're going to be doing is we're going to be making it so that the actual leg that is doing the IK, basic IK solve, is the IK bone structure that we created as part of the initialization. So rather than using the bones, what we're going to do is just delete those. And you'll see that these were set to thigh, calf, foot. Well, what we're going to use is we're going to use the up leg ref, the low leg ref, and the foot ref. And these are going to plug into each of our 3 joints. And what we will see if there's anything else we need to change. Pole vector can stay the same. Primary axis is all the same. Secondary axis is all the same. Our effector is also going to stay the same. All right, and so when we compile this, I'll just go ahead and save this. When we're in IK mode, that's FK. Let's get the IK. When we translate this, what's happening is you'll notice it's already working. Now, our leg is not falling yet because we haven't set it up to fall yet, but look at what's happening. Our IK leg is translating around based on how we move our foot IK control. We know that this is our IK leg because it has all of these arrows and our knee offset on it, which is perfect. Okay, so we now have our basic IK working, which is great. Now what we need to do is we need to get our upper and lower legs to basically align to all this work that we did with the IK chain. So in order to do that, we're going to use aim constraints. All right, and the aim constraints, the way we're going to do it is we're going to take our upper leg, and we're going to aim it not at the knee, not at the IK knee calf. We're going to aim it at this knee offset instead. All right, that way we can, when we move the knee offset, the upper leg is going to point at it. So let's go ahead and do that. So here we go. We've got an aim constraint. Now, when we do this aim constraint, it's easy to accidentally leave this maintain offset checked. The reason I don't want to do that is I want to be able to see problems, and if you maintain offset, you're not going to see those. If we do this right, there should be no movement in our leg when we're done. So first thing I'm going to do is uncheck that. Now, the child that we're aiming is going to be our upper leg when we're in IK mode, okay? So what we're going to do is we're going to get our bones, and we're going to get the item at, where's our upper leg? 0. So let's get the item at 0. That is the child. That is the thing that we're doing the aiming with. Now, what are we aiming at? Remember, I said we're aiming at the knee offset. The knee offset is our low leg ref concatenated with, and we want to use the control here, okay? Underbar knee offset control. This is what we're going to aim at. The item is a control, and here is the control we're aiming at. Now, all of a sudden our leg freaked out. our leg is freaking out because just like our IK solves, etc., we need to make sure that we have all of our aim axes set up properly. So for example, our aim currently is a +1 on X. Let's change this to -1 just to see if it fixes it. Okay, and then we also need to change the facing, the up axis. I'm going to make the up axis 1. Let's try 1 and 0. Let's try -1. Oh, actually, there's two things we need to change. We also need to change our target up as well so that it matches. Let's try -1 here and 0. Okay, so what we've got is we've got our aim constraint set up with our aim axis, our up axis, etc. And then we have not filled in our target space. We're going to talk about this in a second. But just like we do where we specify all of these ifs and everything like that with flip axis, we need to do the same thing for the aim constraints. So let's go ahead and do that. We're going to do that on the aim axis specifically. Let's make this a little bit smaller. And if we have this set up properly, nothing will move because we are currently in, we are currently doing the left leg, and this is set properly. Now, you can see here I've typed in this second vector. We don't need to do that. We can save some space just by scaling it by -1. Once again, that vector knowledge helping us out. If you're weak in your vectors, I have a video for that. Should be a card around here somewhere. You can check that out. Okay, so we have our aim axis set. That's great. Now, let's talk a little bit about this target space. The target space is largely what basically it's in what frame of reference is the rotation for the up vector specified. Now, if we just set it to the world or the leg, etc., things can get a little bit squirrely with our aim constraint. You'll see it start flipping and stuff. One of the reasons that we created an entire secondary chain is we're actually going to use that to help stabilize our aim constraints. So what we're going to use for our target space is actually the bone that is the IK up leg in this case. Let me just double check that. Yes, we're going to use the IK up leg. So let's get the up leg for this one, and we'll use the low leg for the calf. So this is our target space. It's a bone, and what is this warning? Invalid primary target. So we have possibly named something wrong. Let's see if we have our low leg ref is, let's see what the name of that is. We probably have our name incorrect here. Let's see here. We have our calf left IK under knee offset control. The low leg ref is the calf underscore IK low leg ref. I don't believe you. Let's compile that. And let's connect this back in. Compile that again. Oh, like I said, there's multiple compiles. For some reason, that just works. All right, so now that we've done that, we have well, we'll see if we've been successful. Let's go ahead and test our upper leg. Now, what we should see, because we've only done the aim constraint for the upper leg, is we should see our upper leg following as we do, which is cool. And then what we should be able to do now is if we pick our knee offset and we move it, our leg should move to follow it. That's perfect. We're getting there. Okay, so now we need to do the exact same thing for the low leg. Well, almost the exact same thing. We need a name constraint and all that kind of stuff. So let's just take all of this and I'm going to copy it. And what I'm going to do is we are going to change a couple things. So now we are going to aim, this time, the calf. All right, and the calf is going to aim, what's it going to aim at? It's going to aim at our foot. So let's get our foot. Oh wait, this is my blueprint. Let's get our foot ref. And that is going to be here. Now, this is a little different because our foot ref is not a control. Our foot ref is a bone. So we have to change some of these settings. So we'll change this to bone and we'll connect up our foot ref here. All right, and let's just compile that. Now, we do also need to change our target space reference. Remember, I said we're going to use the IK low leg, the calf, to stabilize this. So let's get our, do we have a low leg yet? Yes, we do. Let's grab this. We're going to feed this into our target space. That is still a bone. All that does is it helps stabilize this aim constraint for us. Okay, so now we have our low leg aiming at the foot reference, stabilized by the low leg IK with our axes and everything set up to potentially flip. So what we do not flip. So let's compile and save that. And now when we move our leg, we should get our bending. Perfect. Okay. And when we move this offset, I'm going to try to get a better angle for you here. If we translate this, you'll notice that our leg moves. Now, we have a couple of issues. So let's break these down one at a time. First issue, our foot is not maintaining the proper rotation. So when we translate our foot through space, it's basically rotating. So we're going to do a quick project parent for that. And then the bigger one, where all of the work is we need to set up scaling. We need our knee to be able to scale to wherever the location of this control is. So that's what we're getting into next. Okay, so what we're going to do is at the end, before we get to this constraint, which is our ball offset constraint, let's make a little bit of room. And we're going to, let's start with the foot. Let's fix the foot first, because when we move this control, we don't want our foot rotating. Our foot should be in the space of the foot control itself. So here's what we're going to do. We are going to set a transform. And what we're actually, sometimes when this transform comes up, actually, yeah, this is okay. We'll do this. It's going to be the bone. Let's get our bones. Sometimes I pick the wrong transform and it doesn't have all of the options. The one that we're going to be setting though is the foot. So let's get the item at, where's the foot in the array? 0, 1, 2. So because 0 is the thigh, 1 is the calf, and 2 is the foot. So we're going to be setting the transform of the foot. And the value that we're going to be setting it to is we're going to be getting, global space is fine. We're going to be getting the position of the IK control and basically doing the project to parent. So here we go. Actually, wait a minute. No, we're getting the position of the, let's get the position of the IK foot reference. That's the one we want. So let's do project to parent. We'll double check. We'll find out if this is going to work. We'll do project to parent. And the child is going to be our foot. And the parent doesn't like something. Our parent is going to be, or our old parent and new parent will be, these are bones. That should work here. And this should work there, if we can connect it. Okay, and we're going to take the translation. Actually, we need to connect our transform in first. And then once we do that, we can break this up. I think we have to break up our stuff. So let's just double check this. Let's compile this and move it. Actually, that looks pretty good. That may have just done it. Okay, so let me just double check that all this is working. Okay, awesome. So basically what we're doing here is we are taking our foot, we're projecting it into the space of the IK reference foot, and we're taking that transform and we're setting it for the foot bone. That way our foot actually follows our IK control properly, which is great. So now we have conquered, let's compile and save this. We have conquered our foot problem. Now our next problem is scaling. It's not really a problem, it's going to be a challenge, but we got this. So how do we do scaling? Let's have a quick conversation about scaling. When we scale something, what we're going to do is we're going to take the current desired or no, let's think about it like this. The distance from our thigh to our knee offset, that is the current desired length, okay? The initial length is the distance from the thigh to the knee to start with. If we take the current distance from the thigh to the knee offset and divide it by the initial value, what we end up with is a scale factor. If we take that scale factor and we multiply it by our joint's initial transform values, we are effectively scaling our joint. So that's what we're doing. Let's go through that in practice. And we're going to do that in 2 separate steps before each of, let's see here, here's our basic IK. This is our aim constraint. We'll do it after each of the aim constraints. So let's make room. And I'll recompress the space if we don't end up using it all, but there's a lot that goes into this. Okay, so here's what we need to do. Let's get our upper leg as a reference. Now, remember what I said, we need to take the current distance from the upper leg to the knee offset. So to do that, here's our upper leg. Let's get a transform. And the transform we're getting is of a bone. And we want it in global space because we need to know the actual full distance. And then where we're going to is we're going to the knee offset. So the knee offset, we made one down here. We can copy that. Let's go ahead and get that transform. And that is not a bone, that is control. We do need to make sure that that is set properly. And then what we're going to do is we are going to get the distance between these two. We're going to measure. So let's get a distance between these two. All right, so this represents the current distance from the hip to the knee offset. Now remember what we said we divide this by. We're going to divide this by, so divide, we're going to divide this by the initial length. What is the initial length of our joints? We could measure it, but we don't have to. The reason we don't have to is because theoretically, our skeleton is set up properly and our joint orients are set up in such a way that there is only translation on one axis, and there's only there's generally there should be no rotations at all except for on the top joints. But for example, for the calf, what we have is we have our translation just in X. That value, let's say it's 10, that's the initial length of the bone. So if all we do is get our low leg and we get the transform of it, we plug this in, it's a bone, and we get the initial. We want it to be the initial, and we don't want it to be in world space. We want it to be in local space. So what we're doing is we're getting the initial translate X value. Okay? And remember, that's because our joints are oriented so that X is down the axis. So the actual translation amount of this joint is the length. So we now have this right here. Let's comment this. This is our scale factor. Scale factor. So all we need to do is we need to take our current joint, or we need to take our initial joint length of the thigh, multiply it by our scale factor, or not our, I'm sorry, lots going on. Okay, we need to take the translate X value of the calf, multiply it by the scale factor, and it will actually translate in space to meet the point. So let's go ahead and do that. This is our low leg ref. If we get the transform of the bone, and the trick with this one is we need to get it in local space, because remember, we only need the X value. And actually there's one other thing we need to do in here. Hold on a second. I'll explain that in a second. So this may freak out when we do this. So this is the initial X length, and we're going to multiply by our scale factor. And then what we're going to do is we are going to eventually, up here, we're going to set the translate X value of this bone. But before we do that, let's talk about something down here in our bone initial. Okay, when we get the translate x value of our joint, that number is not always positive, because remember, our right side or left side, depending on how your character joints are set up, it could be a -10, it could be a +10, who knows? So what we want to do when we're calculating distances and scale factors is get the absolute value of this. Anywhere where we're potentially getting a negative number when we're doing distance calculations, we're going to go ahead and get the absolute value of this. That way when we connect it in, we're okay. So this is our scale factor. We're multiplying it by the joint's initial or the current value. And then what we're going to do is we're going to feed this in. So let's go ahead and do that. So we're going to set a transform. And actually I said initial and I meant initial. So we're gonna have to change that real quick. We want this to be the initial, okay? Because we need the initial value multiplied by the scale factor. And that's where we're going to set the current value to. So let's go ahead and take this, not the up leg. Actually, I have the wrong thing connected in here. This should be the low leg, you all. I'm saying the right things, but I'm connecting the wrong. Oh, no. This is because this is I copied the wrong one. Okay, so here's our low leg. Our low leg initial length. We're going to set the current low leg length. It is a bone. Let's put this up here. We're going to set the current low leg length. And let's connect this in. We always seem to get the fact that didn't freak out yet is amazing. Let's go ahead and get a make transform. Make transform. Because what we need to do is we need to set all the values that we want to plug into this for this to work. And we're going to be doing this in local space. This is important. So we'll do this in local space, and we're going to feed in this to our x value. So here's what we're doing. We are taking the initial length of our calf, our low leg. We are multiplying it by a scale factor, and we're going to use that to set a transform. Now, because we're doing this in local space, we're going to be setting the x value and everything else to 0. Our rotations and scales, our rotation should be 0 because it's a properly oriented joint theoretically, and we're just going to plug that into our value. Okay, so when we compile that, you'll notice that what we have is, let's see here, that's local space. Let me just double check. Let's see what happens when we move this. Okay, we do have scale happening. However, it's not reaching our destination. So let's double check our logic here. We're getting the distance from the up leg to the low leg in global space. We are dividing that by the low leg's initial x value to get a scale factor, and we were multiplying that by the low leg's initial x value and feeding that into the local space of the bone. Here's our problem. We don't want the low leg ref here. That's not what we want. We want to actually be setting it of the actual bone. So let's, I have no idea. I hope that didn't do anything weird. Okay, so let's get the bones. We want to be affecting the actual bones that are connected to our character skin here. So let's get the item at, and the bone that we want to be affecting here is the calf, which is at index 1. That is the one that we are going to feed into here. All right, that already looks better. Look at that. So let's compile that. It's just, oh no. Whatever it was, I clicked. Oh, we may have just stumbled on the hotkey to bring our controls back. Y'all, T. That's huge, T. Okay, I'm gonna remember that. Hopefully that is the reason why I've been accidentally pressing T and didn't even realize it. Okay, thank goodness we don't have to restart. All right, so now we have our leg. If we translate it, it should still work just like our IK leg does. Now, however, when we translate this, our upper leg should be stretching. It's perfect. It's actually lining up nicely. It is making it the distance to our knee. Now, we do need to do the exact same thing for our lower leg. Repetition is good. We could take this whole thing and create a function out of it, but that wouldn't give us the chance to do repetition. And here we are, item none is not valid. Let's compile that. Oh, look, magically that error goes away. It's not none. I don't know why it gets confused sometimes. Okay, so here's what we're going to do. We're going to take all of this and we are going to copy it. And we are going to paste it after our other aim constraint. So we need to make some room after that aim constraint. Let's paste it down here. Now this time is a little bit different. So hopefully this is starting to sink in. First, we need to figure out our scale factor. To figure out our scale factor for the low leg, we need to calculate the distance from where? The knee offset. So the first item that we're going to use is our knee offset. So we need the distance from our knee offset, which is a control, not a bone, to our foot. So let's get our foot. Do we have a foot around here we can use? Yep. Let's make sure we're on the right one. Yep. So we're going to get the distance to the bone, which is our foot. Okay. Let's compile that. And then we're going to get the initial length, not of the low leg. We're going to get the initial length of the foot ref. Okay, we're going to get the absolute value of it. We're going to calculate the distance. We're going to do a divide. Now, what are we dividing by? We are going to divide by our foot translate x. So this is going to be, we're getting the initial transform of the foot. Then we're dividing that, we're multiplying that by our scale factor. We're making a transform out of it. And then what joint are we setting? We're setting our original bones, this time the foot. The foot is actually at index 2. So let's move this up here. Oops. And see if we can connect this in. All right, now let's compile that. So theoretically, if we got that right, okay, those are all hooked up. This is our scale factor. Let's just test it out and see how we did. If we translate this up, first off, we should have most of our default. Everything should look good. Don't get confused. This is our FK leg back here. By the way, we still have the entire FK leg to do. This is a beastly forward solve. Okay, so now if we're right, if we did this right, what we can do here is we can now stretch. Take a look at that, y'all. Our leg is stretching properly to meet our offset. Our lower leg is sometimes smaller, sometimes taller, etc. Now we do have a problem. Notice the problem? Our twist joints are not adjusting. So in order to really make this sing, we kind of need to account for the twist joints as well. So before we do that, let's compile and save. All right, so to account for the twist joints, let's just go ahead and take our advanced IK leg and let's add two new arrays. So if we grab this, now I'm going to do a tricky thing here. When you click this plus on inputs over here, it will add a variable of the same type of whatever the last item is. I don't want a boolean. I want these rig key elements. So I'm just going to temporarily move the boolean up 1, and I'm just going to add, and you'll see how it added nulls. This is going to be our up leg twist. And then I'm going to add one more. And this is going to be our low leg twist. And then what we're going to do is let's just move all of this stuff up. So we're all lined up. And now that we have those, let's compile and save that. And then let's get those values and plug them into our advanced leg. Easiest way to do that for now, until we fully proceduralize everything, is to just grab them from the hierarchy. So actually we can just do a search. So let's get our thigh. We're doing the left first. We'll pick both of those and drag them in. Let's create an item array out of those. And we're going to feed that into our up leg twists. It's important to get up leg versus low leg because the scaling is different between the two. Let's get our calf twists, drop this in. Let's make an item array out of it, and we should be good to go. Okay, so now if we go back into our advanced solve, all we need to do, since we already have this scale factor defined, all we need to do is set the translates of our twists. So what I'm going to do is I'm going to, let me get rid of this search, and in my blueprint, compile, save. Let's right click and get the up leg twists. And here we're going to go for each of these. What I want to do is I want to, let's set the transform. And we're going to set the transform to be we're also going to get the transform. Get the transform. We're going to get the X value, which is here. And we are going to multiply that by our scale factor. And our scale factor, this is why I commented it, we want to make sure we get our scale factor. We're going to multiply by that. We're going to make sure we're still in local space, which we are. And we're going to, let's make another transform just like we did here. Copy and paste that. Feed that into our X value. And we're going to set that into our transform. And then what we'll do is we are going to, when we're done with this, we're going to continue on our merry way with the completed, and in the meantime we'll go through the execute, and the execute is going to go into here. Okay, so we messed something up, and that is because we got it in global space. We need to get this transform in local space. When we do this, we shouldn't see our leg freak out. Now, theoretically, if we got this right, what we should see now is we should see, let me just make a little bit of a visual here. What we should see is we should see, as we move this knee, we should see our up leg twist. That's the wrong knee. As we move this, we should see our up leg twists translating as well, which they are, which is great. Because without that, they didn't go all the way. So now we just need to do the exact same thing for the low leg. So I'm going to copy all of this, and we're going to once again make some room. Oh, wait a second. I put that in the wrong place. I put that in the I put the up leg twist in the low leg section. So let's get low leg twists and switch these out. Okay, so now our low leg is correct. I was too zoomed out when I did it. All right, so that's our FK. This is our IK control. So now our low leg twists are the ones that are actually adjusting. You can see that because as we squash them down, they get closer together. They didn't do that before, which is great. So now let's paste this into here. Okay, and once again, when we're complete, we'll go about our merry way. These are our up leg twists. We're going to set all those values. Everything should be good. Let's go ahead and compile, save that. Now, when we move our leg off into space, if we grab the knee offset, we should now be able to stretch our knee. And the cool thing is, this offset will be maintained. So now it doesn't look like our up leg twists are actually changing, does it? So we must have missed something. So here's our up leg twists for each one. Oh, we're not actually doing the multiplication. We missed connecting the multiplication. So let's connect in our scale. Make sure you get it from the scale and not from that make transform. Connect that in. Okay, compile and save. Let's try that again. Theoretically. There we go. That's what we want. Now the cool thing is, as I was about to say, is this maintains the offset. So as we move our leg, you'll notice that offset is maintained. And Team Anim usually, there are a lot of cases that they're very happy to have this control, which is great. Now, the cool thing is we're going to be able to use this control to help us basically solve that difficult FKIK snapping problem later. So here we go. Now, let's see, we have our entire left leg set up and ready to go, which is great. So now let's go ahead and basically just plug this into our right leg. So here we go. Let's take our advanced IK leg, and we're going to once again hijack all of our bones, controls, and nulls, and then we'll make sure our flip axis is checked. We'll feed this in, we'll delete this. We're going to get our twists from our hierarchy, and we need our right twists this time. So this is our thigh. Let's make an array out of this. That's our up leg. And then let's make an array out of our low leg. We're doing this because we want to make sure we didn't miss anything that might need to be flipped or an absolute value or anything like that. All right, so that's cool. This is currently not connected, so we do not see the update yet. So let's go ahead and connect this in, compile, and save. Okay, nothing exploded. That's good. That's always good. And let's go ahead, and we know our left leg works. Let's just try our right leg. So first things first, as we move it, everything's great, which is awesome. Let's go ahead and take our knee offset control and see how it does. It's awesome. Okay, that is great. So we have successfully set up the forward solve for the IK portion of our leg. We are 47 minutes into this video, so what I'm going to do is I'm going to split this out. And as always, if you have energy, I haven't put you to sleep yet, the forward solve for the FK leg is going to be the next video in the link. There should be a link floating around here in a card or on the end screen. For everybody else, as always, throw your comments down in the comment section below. Big shout out to the community, everybody on Patreon, all of those who are helping spread the word. We appreciate your support in all forms. My name's Kevin. I'll see you in the next video. Take it easy.